What does it take to do the most important job in the world? More than 100 years ago, a young farmer in rural Germany spent much of his time fixing a notoriously unreliable hay binder in order to get the job done. So, he went on to invent a better tool. After starting his company in 1913, August CLAAS began a long line of innovations designed to simplify the lives of countless farmers around the world. Today, the company proudly supports over 11,000 employees, 5,000 patents, and 500 different products sold in more than 160 countries through 35 production and sales facilities and hundreds of importers and dealerships. Our customers, independent, business-minded ag professionals, pay attention to the little things because they know they make a big difference. Bright minds who demand more from themselves, the land they live on, and their equipment. We're here to build them brighter tools to help them achieve their goals. Tools like our global industry-leading Jaguar forage harvesters, outstanding hay and forage tools, top-performing tractors, and the unequaled Lexion Combine. Equipment designed to save time, increase productivity, improve profitability, all while providing our customers with greater insight to make brighter business decisions. And make the most important job in the world just a little easier.
Thank you for considering to work with CLAAS Omaha for your Senior Capstone Engineering Design project. I'm Matthew Cook. I'm the Director of Manufacturing for CLAAS Omaha. And behind me is arguably one of the most complex machines in the world. This particular one is made in Omaha, Nebraska. Today, a modern combine harvester utilizes various functionalities to efficiently harvest the grains needed to feed a growing population. In the last 20 to 30 years, the complexity of these machines has increased significantly. From high horsepower engines to the drives to threshing, separation, a multitude of other functionalities that allow a farmer to efficiently harvest. That combined with new technologies, GPS, auto steering, data acquisition systems, these are all combined to make the farmer's job easier. But one thing hasn't changed in the last 20 years. It's the number of bolted joints used to make machinery such as what you see here in front of you. Here you see examples of where our technicians have marked manually the bolted joints when they've reached torque with the specified tool that they've used. And what we would propose is that we develop a system, an add-on to our torque tools, that would systematically, mechanically provide a witness mark upon the tool's completion of its torque cycle. This is an example of one of the air-powered tools that we use on every single bolted joint on this machine. Whether it be a manual click tool, an air-powered tool like this that costs maybe $3,500, has an accuracy of about 5%, to DC-powered tools, every single bolted joint on this machine is torqued to specification. What we would propose is an add-on solution to this tool that takes the signal from the clutch, the vibration occurring as the torque tool reaches the set torque limit, or the air exhaust coming out the back end that occurs at the same moment. Take that signal, process it, and provide a means to provide this witness mark to the bolt head. The proposal that we're providing you today would not only benefit the production of this Lexion Combine in Omaha, Nebraska, but it would as well be useful for the other various products and facilities CLAAS has worldwide. It's very apparent that the quality control that we're pursuing with this idea isn't applicable only to CLAAS, but instead to our competitors, as well as a wider range of industries making very complex machineries with a very complicated arrangement of bolted joints. We hope you choose to partner with CLAAS to address this very important topic. And now I turn it over to Chase Goddard, our manufacturing engineer for CLAAS Omaha, to discuss more of the purpose and the context behind this proposal.
Thanks, Matt. We'll head out to the production floor and look at these pneumatic tools in operation.
Go.
All right, here we are on the shop floor. Assembly technician Dennis, he's going to demonstrate this fastening joint here. Go ahead, Dennis. So he'll go through, tighten all these bolts down within an assembly, and then once he's done, he visually marks them. Here, this has already been done with blue paint. Those have reached the desired torque values.
Same place, you got more of the other. Over yon.
And then he'll go through and mark with a paint pen to show that his torque has been achieved, so it can visually be inspected by quality. Alright, so here's another example of maybe a tight fitting area where an air powered tool would be needed. Again, tight fitting area needs to have minimal interference with the machine, and we mark with the paint pen to visually see again afterwards. Alright, here we have an example of a little bit larger air powered gun, 207 Newton meters, so here we go. Hello, and here is some additional information on the bolted witness mark functionality for the UNL Senior Design Project Proposal. So here we see some existing technology as far as items for witness marks. These are on torque tools that do not have air-powered pneumatics behind them. We see there's a small paint mark near the head of the bolt. So that's what our goal here is to try to do, is to apply a witness mark to the top side or next to the bolt that has been torqued using this Atlas Copco torque tool. So the scope of the project is to develop an add-on device to existing Atlas Copco tools, and we'll get into some of the requirements next slide. So this is the second year CLAAS is sponsoring this project. Last year we worked also with UNL for the witness mark proposal, and we have the first year. Last year we were basically providing yes, this is a functional mock-up, as we are able to prove this in, and we are able to get a witness mark. Now we can see here it's quite large and bulky and not the best to be used in a shop environment. So that's the goal of year 2 is industrialization, fine-tune the witness marks so that there's no misfires, and make sure that we're able to allow this to be used in a shop environment. So into some of the constraints and considerations that we have is that it's got to be low profile and be able to work in tight spaces, as you saw in the video. We have to have a quick drying and permanent marking ink. Last year we found Dicom to be a really good solution. So we have a very large tank for Dicom currently, but that would be a part of the project to minimize the amount that we currently store with a smaller tank, and to minimize or I guess instead of minimize, ease the ability to change out the Dicom or other marking medium if we find something else, maybe a better solution. Must be reliable and durable, and here industrialization on a large scale, so perhaps in some coding that we have in order to mark the bolt. Once we have a vibration sensor that senses when we have reached the desired torque, be able to just adapt some code to use a different torque value. And here we do have on battery power supply and utilization of the air pressure. So there is some charging required. And then obviously large, small, various sizes of air tools, and then obviously different socket head sizes. Some of the technologies that will be used, we have sensors like accelerometers, some pneumatic controls, different valves, paint and ink marking, controller and programming, power supply, component design, machining. So with some of the valves and smaller valves, there was some machining as well. So with that, CLAAS is able to assist on the budget, guidance, and providing access to machining and forming technologies, as well as, you have some access at UNL as well. And our partner Atlas Copco, who also, they make the tools, they are able to assist in maybe some technical knowledge and direction. We thank you for watching this pitch video, and hope that you would partner with us for this witness mark torque tool.